Hey everyone, welcome back to another SAT math video. This is a question from the 2024 official practice test, bundle 6, math module 1. The table shows three values of x and their corresponding values of g of x, where g of x is equal to f of x divided by x plus 3, and f is a linear function. What is the y-intercept of the graph of y equals f of x in the xy plane? Well, you might think, oh, this is a pretty easy question. I know that the y-intercept is always going to be where some point in one part of the point is equal to 0. I see a 0 right here. Maybe it's going to be this question D, or this answer D, 0 comma negative 9, because I know y-intercepts kind of look like that, right? And this kind of looks like a y-intercept. Well, if you thought that, you would get absolutely wrecked by this question because, one, that's not a y-intercept, and two, that would be for g of x, and we're being asked about f of x, right? So, luckily for you, you got me, and I'm going to hook you up with the answer real quick. So, first thing first, they are asking for f of x, right? So we need to basically rewrite this equation and figure out what does f of x equal. They give us what g of x is equal, but we want to know what f of x is equal, right? So all we got to do is a little bit of algebra and isolate for f of x, right? So f of x is equal to x plus 3. How do we get f of x by itself? Well, we can treat f of x like any other variable, and we can treat this, just like a single variable itself, right? We have some quantity x plus 3. And if we want to get rid of that from the division part, we just multiply it, right, by the same amount. So this quantity x plus 3 gets canceled out. And then we do the same on this side as we did on the other side. So then we get f of x is going to be equal to g of x times the quantity x plus 3. So that's the first part done. Now we know what f of x is, more or less, right? And we have a couple of different values of g of x, right? So what can we do with these? Well, we know that f of x is a linear function. What that means is when you graph f of x on the xy plane, it's going to be a line, right? And what are they asking us for? They're asking us for the y-intercept of this, right? So what I know is we could use a very useful formula for graphs of line called the slope-intercept formula, right? Y equals mx plus b, right? Because one of the nice parts of this format of a line is b will always show us the y-intercept, right? Because that's what b is. So how can we go from here to this y-intercept form? Well, we need to first figure out the slope, right? We need to first do that. And then once we have the slope, we plug in some values of x and y and then solve for b. Well, for finding the slope, we're going to need at least 2 points of this line f of x. We need 2 points on this line. And we are given a couple of values of g of x at a couple points at like 3 different x values, right? So we can use actually 2 of these. We can use these to our advantage and figure out some points of f of x at these same x points, right? So let me show you what I mean by that. If we say wanted to figure out, what is the value of f of x when x equals negative 9, we would just plug in negative 9 everywhere we have an x, right? So that means we would put g of minus 9 times minus 9 plus 3, right? Well, we know g of minus 9 per our table, right? The g of minus 9 is simply just going to be what g of x equals when x equals minus 9, which is 0, right? So we know that this is going to be 0, and then times minus 9 plus 3, that's going to be minus 6, which is going to be nothing more than 0, because 0 times minus 6 is 0. So we know that f of minus 9 is equal to 0, right? And we can do the same thing for another point, right? Because remember, we need at least 2 points to figure out the equation of a line. So let's use this other point, 21. So f of 21 is going to be nothing more than g of 21 times 21 plus 3, right? And then we just solve like we did in the last one. So f of 21 is going to equal g of 21, which is nothing more than 5, because that's what's given in our nice little table. And then 5 times what? 21 plus 3 is going to be 24, which is going to equal 5 times 24. I think that's 120. You can use a calculator to double check me, but I'm like 9% sure that's right. So there you have it. We have 2 points in terms of f of x, or in other words, 2 points that lie on the line represented by the equation f of x. So if we rewrite that over here, just for keeping ourselves organized, when x is equal to minus 9, f of x is equal to 0. And then when x is equal to 21, f of x is equal to 120. Okay, great. We have 2 points. Now what do we do with these? Well, we need to use these 2 points to figure out the equation of f of x, right? The equation of this line f of x, right? To do that, we first start by figuring out the slope, right? We have 2 points. We can figure out the slope. Slope is nothing more than y2 minus y1 over x2 minus x1. Pretty straightforward. You've probably seen that like a billion times in your math class, so I'm not gonna keep explaining that, because I'm sure you guys are experts at that right by this point. In any case, we have our y2. I'm just going to consider this our y2 and y1, right? So our y2 is going to be 0 minus y1 is going to be 120 over x2 is going to be minus 9 minus 21. That's going to be minus 120 over minus 9 minus 21. That's going to be minus 30. So m is going to be equal to minus 120 over minus 30. The negatives cancel out, and then we can divide this further, right? We can actually cross out the zeros, because that's just something that you can do to make fractions a little bit easier to work with. So then we get 12 divided by 3. That is going to be 4. So we know our slope for this line is equal to 4. All right, so now we have a little bit more information, almost close. Right now we need to figure out what b is, right? So we have m. Do we have y and x? Well, yes we do, right? Because we have a couple of points already figured out from before. So now all we need to do is plug in and solve for b, right? So let's just recall y is equal to mx plus b. That's the equation of our line. We know m is equal to 4, and we can plug in a point, right? So let's just use this top point right here. So we know 0 is equal to 4 times our x point corresponding to 0 is going to be minus 9 plus b. That is the equation of our line for this given point at when x is equal to minus 9. And now we just need to solve for b, right? So b is going to be equal to, well, actually, let me just evaluate that first a little bit. So 0 is equal to 4 times minus 9 is going to be minus 36 plus b. And to get b by itself, we just need to add 36 on both sides, right? So then we're going to do plus 36, and that cancels out. And we are left with 36 is equal to b. In other words, our equation of the line is going to be y equals 4x plus 36. All right. So what does b tell us again? Well, recall that in slope-intercept form, b is the y-intercept, right? So if we know that b is equal to 36, the y-intercept for this equation f of x will be 0, 36, right? Because y-intercept is nothing more than the point at which the line touches the y-axis, and the y-axis always will be where x is equal to 0, right? Hence we have 0 all along here. So this was a kind of complicated one, not so much complicated, but definitely a little more time consuming. So if you have any faster ways to figure this out, please let me know in the comments below. I'd love to hear what you guys got. I think this way is pretty fast, so long as you know how to isolate f of x from this, from terms of g of x, right? So that was the first step. And then you had to figure out at least 2 points of f of x, and we did that by plugging in some of the values of g of x that we had already over here using our table. We couldn't just make up any value of x because we don't know what the equation of g of x is in terms of just g of x and x itself. So that's why we had to pick 2 points from their table right here to get our points corresponding to f of x. Once we had 2 points corresponding to f of x, we basically figured out the slope and then plugged it into our slope-intercept equation to solve for b. So a few different steps here. This is definitely a hard problem, but now that you know how to do it, I'm sure that if you came across a similar problem in the SAT, you would absolutely crush it. So let me know again if there's anything I can do to improve these videos or this video in particular. Check out Khan Academy. They have a bunch of great resources on the SAT and ACT, as well as other subjects in case you like to independently learn. And of course, thank you so much for watching, and I'll see you in the next video.